All right, for number 6, we're going to use a calculator first, but then I'm going to also do number 6 the way you're expected to do the rest of the homework. And this should be all you need. So, first of all, using a calculator. What's the value of this summation expression as I goes from 1 to 4? So first we'll hit y equals and enter that expression, but instead of using i's, we'll use x's. Next, you're going to hit the stat button, and when you go there, you clear your list if there's anything in there. And you can clear your list just by up arrowing to highlight list 1 or list 2, and then hit the clear button and then the enter button, and they'll be clear. In list 1, since our index is going from 1 to 4, let's include the values 1, 2, 3, and 4. Now we're going to go and get what this expression is equal to when I is 1 and 2 and 3 and 4. How are we going to do that? Highlight the L2 and hit enter. When you up arrow and highlight list 2, as soon as you hit the enter button, you'll notice that you have a live cursor down here. It's asking you, how would you like to define list 2? And we want to define list 2 as this expression. And remember, we stored that in y1. So we're going to say y1, and we're going to find y1 by hitting the vars key. And then after you hit the vars key, you'll choose yvars, and then you'll choose function, and then you'll choose 1. Then after you enter y1, parentheses, list 1, you don't want to type in the capital letter L. You want to find L1 on your computer screen, which is down by the 1 key, and it's a second function. So for list 1, we're going to do second and then the 1 key. So once again, up arrow to list 2 and hit enter. Then your cursor will be here. We want function y1. We'll get that by doing the vars key and then choosing yvars and then choosing function and then choosing choice 1, which is y1. And then parentheses list 1, because we're going to input these list 1 values into the function y1. And list 1 is in the 1 key above it, so second 1. As soon as you hit enter, these things fill in. And we want to know what the sum of all those is. So we just need to add all these up. Now let's do this with a calculator. We can do that in the calculator by going to lists here, so second stat. Oh wait, before you do this, let's clear the screen. Let's get out of the table, but we are going to be adding up all the entries in list 2 to get the summation of all those entries. So first hit clear to get to our home screen. I think I said this already, but we're going to go to this blue list, so second stat. And after you do blue list, you're going to see this. You want to go to math. So choose math. And then after you choose math, you'll choose choice 5, which is sum. And then after the parentheses, we want the sum of the values in list 2. So we'll do second list 2. And then the answer will pop right up. And the answer is 238. So that's how we could use our calculator to add this up. And even if this was 1 to 200, the calculator could do that very quickly. All right, so that's what the textbook wanted you to practice in number 6. However, when we get to problems below like 7 through 12, 13 through 20, 21 through 24, then we're going to be doing this without the calculator, and here's how. On page 291, there's a bunch of formulas. Now this isn't the formula right here, but let's make sure you know that this means as I goes from 1 to n, we're going to add whatever's over here, which is just k. So when I is 1, we have k. When I is 2, we add k again. And we add k n times, which means this is equal to nk. What about the summation as I goes from 1 to n of I? Well, now the index is actually changing in the expression. So this is 1 and then 2 and then 3, and we add up those values. We could also talk about the sum of the first n perfect squares. The summation as I goes from 1 to n of I squared would be 1 squared and then 2 squared, 3 squared, plus 16 plus 25 plus 36 plus 49 times all the way up to I squared. We could also talk about the sum of the first n perfect cubes. Well, instead of adding all these up, we have formulas for these, and page 291 has the following formulas. And these are the formulas. We already proved this one in class with induction. For period B5, I asked you to try this one for homework. For period B8, I asked you to try this one for homework. And we haven't proved this one, but these are the formulas for the summations of constant of I squared, and I cubed, as I goes from 1 to n. All right, we're going to use these to evaluate that problem from number 6 that we used the calculator for. And after you see that, you'll understand what we expect better. You'll understand better what we expect of you for the rest of the exercises. Here we go. Number 6, using these formulas and not the calculator. All right, here's number 6. Let's find the value and see if it's 238. So, our formulas are all in terms of just the summation of I, or the summation of I squared, or the summation of I cubed. So we need to expand all this and rewrite things, and that's going to look like this. The square of I minus 1 is I squared minus 2I plus 1. And if you expand this binomial to the power of 3, you'll get I cubed plus 3I squared plus 3I plus 1. It's still not quite ready for the formulas. Well, we're going to distribute this summation symbol to each individual term. And we have the summation of I squared minus the summation of 2I, but we're going to write any constant in front. And then the constant 1 will leave, and then I cubed, 3I squared with the constant in front, and then 3I with the constant in front, and then the constant 1. So you see, highlighted in yellow now, we now have the exact form we need to apply one of those formulas from page 291. And so we'll just apply all the formulas. That's going to look like this. All right, if we apply those formulas, it's really fast. We just plug in the n value into the formulas, and we should just about be done here. This is a 30. This is 24. This will be what? 25 times 4, so 100. Here we've got, if this was 30, then this would be 90. You can do it if you want. 3 6 is a half, 2 and a 4 is 2, 2 times 5 is 10, times 9 is 90. Okay, and then here we have, what, 30 and 4. So 30 minus 20 is 10, 110, 200, 230, 234, 238, just like our calculator gave us. All right, well, I hope that helps. Have fun, yay! I have no idea what this is, but I definitely know what this is.